Hey guys, my name is Dino Fumanisa and we're doing the 8.5 exercises on page 157 of your module. I'm doing number 2 and this chapter, guys, is based on depreciation and escalating depreciation. The question reads, number 2, guys, a firm costs items manufactured by charging for depreciation of plant and equipment used in the manufacturing process. The amounts charged is such that the equipment can be replaced at the end of its useful life. The amounts charged are recovered from sales and deposited into a sinking fund at the end of every 6 months. The interest earned by the fund is 10% per annum, compounded monthly. That is our J. 10% per annum, comp monthly. And this is not aligned with our payments, which are every 6 months. P. No, actually it's N. It's every 6 months. And that means we pay into the fund 2 times in a year. Now, they tell us the firm has just acquired a new machine which cost 40,000 and which will have a scrap value of 5,000 at the end of its useful life, of its 6 years, at the constant rate of annual production planned. A new equivalent machine is expected to cost 71,000 in 6 years' time. What we always do, guys, is we take the amount that the future machine is going to cost and we minus the scrap value to know what amount we're going to save up to. So here we give it that it's going to cost 71,000 and the scrap value is 5,000. So we minus that and we get 66,000. This is our future value. This is the amount that we have to save up to. Now we have to convert the interest so that it can be aligned with this payment every 6 months. Now, this is J1, I1. I'm sure you guys can do this now because we've been converting. Go to your calculator, press convert. Our N is 12, our interest is 10, and then solve for effective. It's going to give you 10.47130,674% per annum. But now we have to change the tool so that our second J is going to be press convert again, press tool, and then go to APR. 10.21066266% PA, compounded semi-annually. And then to get our interest effective for this period, press on ends and then you divide by 2. And then you get 5.10,533,1332% per half year. Question A asks us, suppose management decides that the actual amounts charged to depreciation of the machine, in other words, management's cash contributions to the sinking fund not taking interest into account, will be fixed amount at the end of every 6 months. What will these amounts be? And what they're simply telling us, we don't have to take depreciation into account because we already have the scrap value and we already have the future value. So now, since it's going to be a fixed amount, we can do this using the annuity formula. We're going to set up our equation of value. Our future value is going to be 66,000. Payments is what we're looking for, S because it's future value. And this takes place in 6 years, but because we have 2 payments in a year, our total payment is going to be 12. And then using this I2. To find the payments, go to your calculator, compound, and N is equals to 12. Our interest is that 5.10 105,331,332. Our payments is 0 because it's what we're looking for. Then future value 66,000. Press solve on the PNT and we get 4,121.26. Part B of the question asked, suppose management decides that its cash contributions to the fund will escalate at compound rate of 4% every 6 months. What will its cash contribution to the fund be in the first year and in the 6th year of the machine life? Okay guys, since this payment happens every 6 months as it is, and then escalation happens after every 6 months, this means that every payment is going to escalate at every time. This means that you cannot have an annuity formula for this one. We have to draw a timeline, guys. As we said already, there are 2 payments in 1 year. 1, 2. And this is year 1. The first payment is going to be P. The second payment, because escalation happens after every 6 months, is going to be 1.04P. Yeah. In the second year, our payment is going to be 1.04 squared P, and here it's going to be 1.04 to the power 3 P, and so on and so forth. And in the 6th year, $11, and then 12. Our P, if it's 3 here, so it's going to be 11 here. 1.04 to the power 11 P, and here it's going to be 1.04 to the power 10 P. What you do here is you check what's the relationship between the number, the payment number N, and the escalation period. So here the period is 2 and is to the power 1. When N is 3, our escalation is to the power 2. So that's how you get to the power 11 in the payment period, which is 12. So what we do here now is 66,000 is equals to P1 plus I2, which is here. We're taking out this one. Now we're left with 11 payments plus 1.04P 1 plus I2 to the power 10 until you get to this one, which is going to be 1.04 to the power 11 P, and then we have no interest because it's at the end. Like Tina told us in class, when we have this, we can have, we first have to factorize. Taking out our common factor, and we're left with 1 plus I2 power 11 1.04 1 plus I2 to the power 10 1 point, this is the first term, and then this one, and then, we don't have one here because it's the last one. And then our first term here is going to be 1 plus I2 to the power 11, which is equals to 1 plus 5.105331332% to the power 11. which gives us our common ratio is going to be T2 over T1, and that's simply saying 10 minus 11, because when you divide for fractions, you minus the powers. So this is going to give us 1 plus I2 to the power negative 1. And this is equals to, when you substitute I here, zero point 989 483 5845. And we're going to substitute this into our formula, our geometric sequence formula, which is Sn is equals to A minus R to N, and then 1 minus R. .7. Wait, I don't think I'm going to have space. .729307 407. 1 minus our R is 0.9. Four, 8, 3, 5, 8, 4, 5, and this is going to be to the power 12. Our n has to be the number of terms here, which is the number of payments, not the number of years. So it's going to be 12 there. And then 1 minus 0.9894835845. And in total, our Sn is going to be 1.79. Our Sn is this part though. So this means that 66,000, going back to our equation of value, this means that 66,000 is equals to P Sn, which is that 19.59250184. Okay guys, so now we found our Sn, which is what is in the bracket after we factored out P, and then I remembered we have to put in plus here, and also here after the brackets, after you factor things out, after the terms, put in plus, because it doesn't make mathematical sense if you don't do that. And in the last term, put into power 11. You have to put into power 11, but if you don't put the plus, you won't get penalized in the exam. Relax. So we go in here, we want to find P, which is the value of our payment in the first term, and that is going to be 3,368.64. That is our P. The question is asking us, what is the value of P in the first year? And in the first year, remember here from our number line, this is P, and then in the second payment it's going to be 1.0, 4p because it escalates by 4% after every 6 months, and our payments are after every 6 months. So for year 1, it's going to be p plus 1.04p, which is equals to 3,368.64 plus 1.04 this number. And that is going to give us 6,872.03. This is the total amount that we've paid in the first year. In the 6th year, come and check on our number line. It's 1.04 to the power 10 for the 11th payment, p plus 1.04 to the power 11 p. You substitute p here, 3,368.64 to the power 11, no, sorry, times 1.04 to the power 11 plus 1.04 to the power 10, 3,368.64. And that's going to give us a total of 10,172.28. This is what you paid in the 6th year 12 payment. Thank you.